think we're live. There we go. Okay. Heyo.
Welcome everybody to the something fifth installment
Fifth.
and install.
That's right.
I have coffee, I have a soda, which is caffeinated. Does that count?
I have green tea.
Hmm. Here we go.
It's all a lie.
Compilers and caffeinated drinks. Doesn't roll off the tongue.
No. How you doing, Max?
I'm doing well. How are you?
Good. 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 I've been working on this polynomial dialect, uh, getting it
The
upstreamed.
PR. Yeah.
Yeah. There's a PR up there that's like just like the very first PR that I need to get the like initial dialect type in attribute definition in. I think I talked about it a little bit last time, but I like finally got back into the process of get like I had written the PR and then there were some comments and then I waited
Yeah.
6 months and now I'm finally addressed all the comments.
Man, going back to a PR 6 months later is fucking difficult.
Well, it was easy because it was not depending on anything. There were no changes. It was just additions of new files. So there were
Hmm.
no merge conflicts, which is lucky.
Well, it's not even so that's a difficulty, but like just quote unquote context switching back to. I mean, I don't know. You play with this dialect again, I guess, all day, but every day, but it's frozen in time, right? Or whatever you left 6 months ago on
Yeah.
the table, it was frozen in time. So you still got to readjust some kind of thing to get back into mindset, and that's very hard.
Yeah. But yeah, I'm hoping I
So
can get to the point where they just ignore me and let me work on my polynomial dialect without requiring like a extremely detailed review from two or three MLR experts.
who's giving you the most trouble? I
Well,
don't know.
no,
Maybe
no one's
it's
giving me
shit talk.
trouble, but I think it's that like sort of like first commit, because
Hmm.
this is like my first like serious commit that was, more than 10 lines of code, that, requires some additional scrutiny on the maintainers to be like, oh, let's make sure that this is every single project I've ever been involved in. Like the first time you make a change, then like
Sure.
some old timer comes in and
Hmm.
kicks her ass with
Yeah.
nitpicking and yeah.
I definitely remember that. Like I've never submitted what is 22 files. I don't think I've submitted a change that was 22 files, but like 10 files or something, and just bam, like 100 comments. It says you have 100 comments on here, and yeah, man, Alex. So in the first, I think the first meeting we had, is that the one that's spaghetti pasta lasagna?
That was the third one. Yeah, yeah.
Yeah, okay. The third one, really? Okay. Uh, I don't know. Like I guess I'm an okay compiler engineer, software engineer, whatever. But I miss stuff, and always, like once or twice I've approved the PR, and then Alex comes back around and like finds a mistake that I made, and I'm so like mortified. It's amazing. I don't know what it is. Like the level of attention to detail. There's something genetically different where, okay, once in a while I'll catch something subtle, and I don't know if it's because I'm lazy or if because I don't have enough experience or if it's literally just because I don't like there's some genetic defect in my head. But it's like he's catching everything, and just like the guy was catching everything that I was submitting, right? Whoa, there should be a double reference. It should be a universal reference. If the copy constructor, it's the lighting copy constructor, all this kind of stuff. I'm like,
Yeah,
ah,
I'm definitely not enough of a C++ expert to get all of these like little
yeah,
nitpicks. But I
yeah.
also don't think that they are as impactful as they make it out to be. Uh,
Yeah, I tend to agree. Certainly the very nitpicky ones. I mean, but he caught one like Stella put up a PR. This is the most embarrassing one. Stella puts up a PR, and I'm like, I gave it a once over, twice over, and I'm like, I kind of understand what's going. Is in the bindings. So like, I basically understand that stuff really well, and it's also Stella. She didn't, like two things working against me, my hubris and faith in authorities. And then, okay, cool, prove the PR, land the PR. She lands it. And then he comes back around and is like, oh, this broke Jax.
Mm.
and he had to revert it, and it was because of some kind of like ownership issue, or like there's no ownership semantics in C++, but it was some kind of thing like that where like, oh, this was a bad, this wasn't it wasn't a nitpick, it was a glaring issue. Uh, so yeah, so certainly the nitpicky ones are like less important, but it's training. Like when I get reviewed and somebody puts me through the paces, it's like the drill instructor. Like I feel like I'm improving.
Mm.
I mean, I made the claim, right? I made that claim in that episode. But you don't probably. I mean, like it's hard to appreciate. I don't appreciate it all the time. I feel frustrated too.
Yeah, I think it's fine. Um, I don't know. I feel like a lot of it, like I feel like most of the nitpicking should be automated. Like there, I don't.
Automated.
No, I mean like seriously. Like I think, well, maybe I got spoiled by Google, but there's a lot of internal tools that are just like, here's a list of 1,000 just best practices that aren't like they call them like suggestions or whatever, and it will just go through your PR and look for little syntax patterns, or I guess they probably parse the AST for that, and then it'll say, oh, instead of doing if condition return true else return false, you should return the condition itself, right? Like they like have
Yes.
little checks for these things so that reviewers don't have to waste their time on it. Um, and then if the reviewer sees that and you haven't addressed it, they can like click a button that says like require this change. Like if you see an optional suggestion and you ignore it and the reviewer really wants, they just can click a button and it will. And so I feel like a lot of these things was like, oh, I used like a const small vector reference, and they're like, no, you need to use array reference, even though they're the same thing, right? Uh,
Are they?
well, I mean, some like spiritually they're the same thing. Uh, and I was copying it anyway. So it's like, okay, I'm going to copy something that's a constant array or a constant array masked as an array ref. It's the same thing. But like
Is
obviously
the
it's like less code, right? It's like textually less to use array ref, and that's what array ref is for. So you don't have to like have const references of things. Um,
is that so? I don't know that. I actually just managed to scroll to exactly the thing you're talking about. I did not know those. Okay, prefer array ref when taking an immutable range of things. The callee is appending to the vector, small vector and pull. Use small vector. What? Why? He's just like
Yeah,
reading.
there's
Okay.
like, okay, there's other things, but in this case, it's like a constructor that was taking a vector defined by the caller and then making a copy of it and keeping it internally in the class. And so it's like, it doesn't really matter what you pass in. You can pass in, like, as long as it's constant and immutable and you know that it's not being moved or the ownership isn't changing hands, then like it really doesn't matter what you give, but like it's a code-based consistency thing.
Hmm.
I don't know where I was going with that point. I had some.
You got spoiled by Google. You like.
Yeah, and like that's the kind of thing where it's like, oh, there should just be an automated tool that looks for that and automatically adds a suggestion. Uh, I think that's like one of the. I don't like to you know, praise Google tools too much because there's a lot of
Why
things I don't.
somebody built them? Somebody built them. You should like that person listening is
That's
probably like
true.
very proud.
I think that the downside of all the Google tools are that they only work with each other, and so
Hmm.
like I work on NeoVim, and it's like a lot of the stuff doesn't work with NeoVim. Like the like fancy Google things only work if you use Google approved, Google designed editors, and it's like okay, whatever. Um,
Is that only Cider?
yeah, it's Cider, and then they have like a internal version of VS Code that is basically
No.
Cider, but on the desktop. Um, but yeah, so it's like the I think that a lot of the I think there was like a service called like LGTM or something that basically was supposed to be a replication of the like best code practices that got moved to GitHub, and then it got merged into like GitHub uh, code static analysis or something like that. But I don't know to what extent you can like add your own custom rules based on like AST parsing. Um, Yeah. Anyway, that's kind of a total aside, but I definitely think that, 90% of the comments he had to me were nitpicks that seemed like they could be automated.
So do you feel bad for him or do you feel bad for yourself? Because that from
Both,
the way
right.
you're
Both. Yeah. Uh,
don't evaluate end every time through a loop.
I didn't actually
Uh,
know that. I didn't know that. I thought that it would be constant subexpression eliminated, but I guess if it's a function call, like if you have a loop and the upper bound on the loop, the like
sorry.
termination
Yeah.
condition on the loop is a
Yeah.
function call, I thought it would evaluate the function call eagerly and then keep it
Shit, that's
around.
called every single time. Yeah, I guess that makes sense. It's evaluated. I mean,
It kind of makes sense, but I don't think every language does it that way.
I don't know which
Like
language
Python
has a
doesn't do that.
Python build. The reason for that is Python builds the range once.
Right.
It builds the range, so you can't have a function call at the top bound.
Right. And I think most languages do that, where they eagerly evaluate the bound and then keep it around the loop, unless it's a while loop, right?
Yeah, I get. Yeah, it's funny because this is basically a while loop in disguise. Then.
I think that's exactly. I think that's like a C++ism. Like Java, I think doesn't do that. I think Java will eagerly evaluate the function call, but maybe I'm wrong. This is the first time I'm programming for whatever 20 years. This is the first time I've heard someone criticize my performance, loop performance because of that.
So what is the mitigation here? Because the next one looks what is this?
Oh, I just declared the variable outside of the loop.
OIF, right? OIFs. No. Yes. No. Monomials. No, I don't fucking know. But if you click the link he sent you, it's like this is what it looks like and this is what it should. Convenient way to do this is like so. And I'm trying to see what changed.
Oh,
There's
the here I can. Oh, you're saying
oh you yeah okay you cache the end
let
and the
me
check yeah.
yeah, I just cached the end. They had some weird. I can actually bring it up. I have the thing on stream right now. Um, author me, and it's failing the build. Oh shit. Um, yeah, we're talking about this coding standard where it says
Oh, you have it up on stream. Shit. I don't know
so
how you do this because I guess you don't have a lag because if I pull you up on stream,
yeah, there will be a lag. Yeah, I can share it on the.
no, it's fine. I think the smarter thing to do is for me to navigate to the stream without you sharing it so that the I don't know, whatever. Okay, yeah,
Yeah,
that's the
so
one. Yeah,
this and then they have this like weird way of putting it in the initializer, right? To eagerly evaluate it.
yeah, there you go.
Yeah.
Yeah,
Yeah. Anyway.
I don't know. I like that. I mean, that particular one, I think that's a useful kind of thing. Like, this is what I mean when I say, oh, I'm getting a little bit better sometimes with the nitpicks, where like I actually did not realize. I knew that you could stack on the top end evaluation. I think. Like I knew you could put stuff. You could put two statements. You could use the comma
Right.
operator, quote
Yeah.
unquote, in the termination condition. But I didn't know you could do that. But it makes sense that you can do that in the
Yeah.
initial
You could put anything
initial.
there. You could
You
put
can put
any.
nothing. I know that you can even put nothing.
Well, you can put anything. It's any expression can go in any three of those slots can put anything.
It's funny. I've seen those memes about the comma operator. That's not true. That's not an operator. What? How does that work?
The
It just
com.
evaluates. Yeah, it's like a joke. The comma operator in C++, but it's not an actual operator.
Yeah, I don't know exactly.
It
It's
just
like
evaluates both those. It's a trick.
well, I mean, it has a type declaration that's the same for both assignments.
Yeah, it's like yeah. They have to be both the same. Yes, right. This is assignment. This is yes. So it's like float A equals 1.0, comma B equals 2.0. They have to both be same. You can't put different types there.
Right.
Yeah. So it's just one initializer. Or it's one initialization statement. It's one declaration and
One
initialization statement.
statement of any kind.
Yeah, yeah, that tracks. And the fact that you have two assignments is because of C++ lets you, if they're the same type,
Mhm.
write two of them. Yeah, okay, I got it. Yeah. Somebody just messaged me. Oh, or wait. Okay. How did my defense go? Horribly. Yeah.
I hate to hear that, but also afraid to ask more details.
Well, and I'm afraid to actually divulge because I don't want to talk shit because I'm compelled to talk shit.
That's true. Yeah, don't
And
talk
I've been,
shit.
and then I have been talking shit for like the defense was on Friday. Like, I don't know. I didn't fail, but you fight and you fight for however long, whatever, 4, 5, 6 years, right? So this is my 4th year. And then you show up to the thing. This is how I put it actually to my friend Kumar earlier this morning. He's like, imagine you were in jail for even this amount of time, 4, 5, 6 years, and you go as like you know when your parole date is, or you
Hmm.
know when your release date is, right? And then you show up to that day, and then they're like, nope, we're gonna let you out a month from now. You're still getting out for sure, right? Like ultimately, this is what everybody wants me to feel and believe and come to terms with. Like you're still getting out, and that is in fact the case. But just who would not be furious showing up to their parole date? I know actually with a parole date, like no, sorry, the parole date is when you leave, right? Like both of those release date and the parole date, you're out of the jail,
Right.
right? It's like imagine you show up to your parole date and nobody told you before, right? Like you're walking into the parole date expecting what the common understanding of a parole date is. And then you show up and they're like, nope, you got to do one more month inside. You'll be okay,
But for
but
you, is that
you're
a month of like full, like you're working most of your time on like
no.
fixing up your dissertation, or
But that makes it worse, right? In
okay,
my mind, that makes it worse, right? Because it's like, okay, pass with revisions. What kinds of revisions am I revising? Is it like, well, the formula's wrong, the proof is wrong, we need to patch the proof, the data is missing. No, it's like I was looking at the revisions today, and it's like, oh, you used the wrong comma, you used the wrong apostrophe.
uh,
Like you should have just passed me.
yeah,
It's like you should have just passed me and said you should have signed on the paper and been like, fix these things before you submit it. But it's not how it went. So, Windows is the most annoying thing. I don't know who uses Windows. I hate
I
everybody
do.
that Windows. Can you tell me? Okay, fine. Then this is your responsibility.
Oh,
Let me see. Let me see what it says. It basically didn't respect so I'm building a Python wheel. I build these Python wheels, right, that contain the entire distribution of MLIR. You aware of this?
yeah, but I'm not gonna be able to help you with like building things for
No,
Windows.
no. Wow. Okay. Okay. Yeah. I wasn't expecting that you really were able to help. Let me show you this.
I use Windows subsystem for Linux,
Oh yeah. So you don't use Windows.
but everything else is in Windows.
No.
I
Everything
do
else. What
notice
you're
that the LLVM like Windows builds fail a lot more often than everything else.
That is 100% true. I don't know why that is. And also the Windows runners are rarely available for some reason because they're harder to set up. I don't even know who maintains those. NVIDIA maintains one of them. Okay. Anyway, so that makes no sense to me. This PR, so this is like a fail, whatever GitHub action for PR. This PR, the only thing that this PR does is I'm going to copy. So these wheels I build, I package them up these wheels I build, it's MLIR plus LVM packaged up as a wheel. So that's just, I have a setup.py that runs CMake and blah, 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 and then copies the stuff into the wheel, right? So what this PR does is it includes bin/MLIR translate, right? So you know how if you build MLIR, okay, there's a binary directory, and then it's going to have like MLIR opt,
Hmm.
MLIR translate, or hair opt, hair translate, right? And so the only thing that this PR does is it says, okay, take those binaries that I'm interested in, those executables, and package them up in the wheel so that they get copied into your virtual environment/bin. I don't know, whatever the specifics are, it doesn't really matter. The thing is, the only thing that I had to do to make that happen was I'm like, I have a build directory. I fix the name of the temp directory that the actual CMake build is happening in. and I'm going to copy out at the result bin / MLIR translate, and I'm going to put it somewhere. And on every other, you can see, right, like these passed, and this one will pass. The macOS things will pass because the path is fine, right? Like I make this directory, and then that's it, right? I don't know why the fuck you're not gonna be able to answer this for me, but I've had so many issues with Windows and file paths. Like, do you know there's a maximum length file path in Windows?
No way.
Yeah, bro. And it's not that long. Sorry, there's a maximum length file path, and then there are two things that are just absurd in 2024: maximum length file path, and then maximum length line in a file.
Hmm.
And if you build MLIR, you can hit actually both of those, because if you have a file path somewhere that is like, oh, I have a temp directory. Within the temp directory, I have MLIR include blah blah blah, so that you can end up having in your build directory a folder that's like very deep in the build directory, right? Like include this dialect that blah blah. So you could throw up there. But also, if you build a linker script command that links together, let's say all of the libs in LLVM, right, with their full paths. So during build, I have like, I'm going to link affine.lib, hair.lib, right? I'm going to build like this giant single schlib. You need the full length file path, right? So it's a linker script. It's like, oh, I'm going to join this lib to this lib to this lib to this
And
lib
that's just a
times
huge
100.
long line.
That's correct.
Yeah.
In your build.ninja or whatever the thing that actually does the linking, right? And that'll break. And I hit that. It was like I had to copy the Windows directories into like the shortest /temp/c/a, and that's it. And then it would work on GitHub, because by default GitHub puts all your stuff into like /home/target/runners, right?
Mm-hmm.
And that blows up the path. Anyway, a small rant about how absurd Windows is. The other funny thing is Microsoft owns GitHub, right?
Mm-hmm.
Microsoft owns Windows, right? This is good. You're like,
This is
what the
news
fuck?
to me.
Yeah, exactly. Do you know that the Windows runners on GitHub are 2x slower than both Linux and Mac runners?
Yeah, I believe that.
You can find numerous issues with people being like, my build takes this long on a comparably sized and spec'd Linux runner. It's 2x as fast compared to Windows whatever server instance blah blah thing. And I'm just like, isn't that such a bad look for your company that your own service on your own operating system underperforms your competitor? I don't know. It's just funny. It's like if Google it's like if Google used AWS because it was faster. Do they? Are you gonna
I
say
cannot
something like they
comment.
do?
No, I
No.
don't know, but what?
Or like Bing? No. Google actually used Bing. That's
funny.
funny.
Yeah. I feel like I don't know. I heard some people doing some like weird stuff where they will like do like multi-cloud backups. Like they'll do like not just keeping their files on two different clouds, but like putting like cryptographic secret shares of their files on two different clouds, so that like if you need access to like both clouds to get back the file, which is kind of a
Like
weird thing.
those, like turn both keys to
Yeah,
fire
yeah,
the
yeah.
nuclear
Well,
missiles.
have you heard of like secret sharing? It's this thing where you can like take any piece of data and split it up so that you need like at least k of n, like
Mhm,
so at least 5 out of 7 of the shares to reconstruct the
mhm.
secret. Uh,
I know about MPC, multi-party compute, or whatever.
mhm.
That's in that same like
Yeah,
universe.
that one uses a lot of the same ideas.
So they split them up on cloud, but why? I'm
I'm not sure. It seems like it's actually more like if any cloud is down, then you can't get your secret. I think it's like, oh, they want to make sure that like if someone breaks into one of their like cloud storage platforms or whatever, or like protection against internal leaks. So like in order for Amazon or Google to spy on you, you'd have to have a mole in both companies basically to like get
who
right. Yeah.
who has stuff like that? Do people? Is there a company that has like what are they building? The
and,
Stargate?
and nukes, put nuclear secrets on public cloud.
Yeah, exactly. That's what I'm thinking of. Like Raytheon or whomever. I actually just learned about that. There are these boxes. I forget what they're called, but they're basically large Faraday cages and all this kind of stuff. But they're like it's a Faraday cage big enough that you could sit in, and so like if the president needs to review some top secret documents away from, so they have that you can buy them and also they distribute them to consulates and embassies. So like if you need to within the Ecuadorian or Russian or embassy in Moscow, the U.S. embassy, to review some documents, some digital documents
Yeah.
that
They
are uh, they put you in a box.
Yeah, they have this in U.S. government labs too. Uh,
Yeah,
I have seen one but not used one, where they were like, oh, if you want to like look at this data that we have, then you're gonna have to like get a pat down, take your phone out, get a pat down, and then go into this room that is a Faraday cage, so you
but
can
what I'm saying,
so you can read the data. And I'm like, but I don't want to read the data. I want to process the data. And they're like,
well,
sorry.
so what I'm saying is that doesn't get anywhere near the cloud. Who is what are people storing on public cloud? It is that
I
sensitive.
don't think
It's
this is a
that
practical thing, dude. I just heard of
uh,
someone doing it. I don't know why I thought of this.
yeah. Speaking of crypto,
Speaking of
uh,
crypto, do you want to talk about your
yeah, there's nothing.
foray?
See, yeah. So it's because I just wrote that guy an email like 45 minutes before I went out for groceries. Because dude, funny sequence of events. Had a half-hour meeting with this guy, right? Like ostensibly an interview for a job, and then immediately right after I had scheduled them back to back with that horrible like I'm gonna pitch my manager on promoting me above him meeting. I wasn't actually above him. I'm just saying it was like
Hmm.
this reach thing. So it cut off in the middle of the so the meeting cut off in the middle of the conversation, and I'm like, let's talk again. Very optimistic. And so I was writing him an email back today. I'm like, yes, I scheduled more time on your calendar, but in the meantime, let me give you some thoughts from our previous conversation. So, and the other funny thing about that meeting is he he found me through that repo, that AMD repo that I contribute to,
Hmm.
MLIR and he also reached out to my manager. And I believe the way that he picked both of us was we are the top two contributors.
Ah,
And so
give
3 days ago,
give
my manager had a meeting
give our listeners some context
about MLIR or
about the
this.
job, about the job.
Oh yeah. So I don't come. I mean, this is why I brought this up because you can give me some more education live and on air. So I called him a crypto company and he got a little bit offended. I guess he doesn't see himself as a crypto company.
Well, if it looked like they were doing blockchain, that
Uh,
was their main thing.
is ETH technically blockchain?
Yeah,
Okay, sure, fine,
yeah.
fair enough.
Like it's Ethereum.
Yeah,
The way I saw it was they do zero knowledge proof systems for the Ethereum blockchain.
yeah. So an API so that you can write a contract that proves that the contract got evaluated or proves some aspects of the contract with zero knowledge guarantees, ZK not guarantees or whatever, right? Something like that, right? Like I watched this little stream that he did like 2 months ago, where he's like, this is our SDK, this is our API, and people can write smart contracts and use our API that confirms, validates whatever in a ZK way. Anyway, my manager and I both thought, well, this guy is interested in us because he wants to implement some heavyweight NTT thing on FPGA, right? Like that's part of the value chain bottleneck cost of doing business that he wants to fold into and take on and vertically integrate, right?
Hmm.
like, oh, we're gonna start co-locating FPGAs with wherever, I don't know, like they have wherever they host their web services backend, they're gonna be like, this was our hypothesis. Oh, we're gonna AWS, we're gonna lease FPGA instances, and we're gonna run NTT instead of buying NTT or doing the slow implementation through Rust, right? So there's some Rust library. That's what I thought going into it, that he was going to be like, well, can you do FPGA? And I'm like, no, because I'm not good at RTL, right? Check this out. Turns out what he wants is indeed a compiler. He has, you know this thing called Halo 2? You
I've
heard of
heard of it.
this?
Yeah, yeah, yeah.
So this is a ZK circuit evaluator library framework, however you want to call it. I don't even know what to call it, but like you can specify and evaluate the ZK
I
circuits.
think it's like an interpreter for like zero knowledge proof systems.
But
But yeah, I just learned about this like 2 weeks ago. Uh, but
so
so
what?
so they use that.
They do. They use that, and they're like, you know, something heavy contributors. They're both like these dudes from like I guess they met at they're like Harvard, MIT, and then they were both professors at TT. They were both TT at U Chicago, and they
Okay.
are on leave. Uh, so they're like major contributors or something. But what I don't understand is, okay, it's an interpreter for ZK proof systems, but ultimately, what does that mean? Because I don't understand the framework. I boil it down to you got to evaluate the circuit, and it's a computationally hard problem.
Yeah, but
It's equivalent to whatever your thing
each
is. Why
gate,
yours is hard?
it's not equivalent, but I think if I have like a list of things I've been meaning to like learn about this to get a proper understanding of it. But my understanding is that the way the zero knowledge proving systems work are you basically have a circuit, and then at each gate, basically you're like proving the evaluation of the circuit evaluates to true by proving at each gate that it evaluates to whatever the supposed gate output is, and then like propagating that all the way through. But then the proof for each circuit involves basically like committing, like cryptographically committing to some polynomial, um, and then allowing someone who wants to verify it to choose like random inputs to that polynomial and get the values of the output for that input, and then use that to say, okay, if I've tested enough of these polynomials, then like I know that your commitment is consistent, and then they use that to like combine everything together. Um,
Where's the ECC? Where's the group?
I don't know. I don't know where the ECC is. Like I know that there is ECC in it, but I think that uh, yeah, there's something about like witness. Yeah, so there's something about like the arithmetization, the generation of the circuit, and then there's
Yeah.
something else about like generating witnesses for the proof. Uh, and I think that like both of these have their own like performance issues, and I think that the arithmetization is mostly like polynomials and coming up with like your commitments and stuff, because then you publish that and you have to publish your commitments in advance of anybody verifying the commitments. And then when you verify the commitments, you basically you do it with randomness, and it all kind of boils down to the fact that like two polynomials have to agree on at most a certain number of points before they are just completely equal. Like you can't have two different polynomials agreeing on
Mhm.
less than like agreeing on more than the degree number of their points without
Yeah.
agreeing completely. And so they use that to say, okay, I'm gonna like evaluate these polynomials, and maybe I don't know, maybe it's like in somehow in an elliptic curve. Um, yeah, I don't know enough about it to say exactly.
There's
Uh,
two primitives there. If you read the docs for their thing, they say that there are two primitives you can use to implement the hard bits. One is ECC and one is hashing. Okay, anyway, whatever. Some more reading required there. But the thing that he wanted was, so they have some fast implementations. They have essentially kernels. He didn't use that word,
mhm.
but the closest thing that I could translate it in my conceptualization of whatever I do is, oh, they've got a kernel library. some fast implementations of whatever difficult bits components of the system. But they so the kernels handle like the equivalent of a convolution, but they have arbitrary programs. They have arbitrary circuits. They have arbitrary ZK circuits, and they have fast kernel implementations for some sub circuits, for some common patterns. I don't know whatever the equivalent of. Hey, I have a neural net, and that neural net is arbitrary, but within the neural net are embedded
Hmm.
convolutions and matrix vector models and whatever, and I have kernel implementations for those. And they're like, it's a standard it's a standard compiler problem. Hey, I have arbitrary programs. How do I pattern match on what I have kernels for? It's what subgraph isomorphism is, right?
Hmm.
Like that's my personal understanding of the kernel library problem in ML. And so I'm like, oh, you have the same exact problem. I have arbitrary programs. They're circuits. They're ZK circuits. So whatever program means in the sense of a ZK circuit, like for you, a circuit model is equivalent to a program. And whatever it means here, I have no idea. Maybe it means something completely
It's
different,
also
but
got
they
to be
have,
circuit model. Yeah.
yeah, yeah, yeah. And they can evaluate sub circuits very quickly. But they enable people, their customers, to write arbitrary circuits. Now, this wasn't clear to me. I don't understand how he surfaces to the customer because his API that he demos in the podcast or stream is just like, oh, I'm writing a contract. I specify a schema. There was like he has a TypeScript. He had a TypeScript API for the customers to use when writing the smart contract for uh, Ethereum. So I don't know where he's getting like arbitrary ZK circuits that he then needs to evaluate very quickly. But they're somehow. And he was like, "Oh, we have Rust level representations of these ZK circuits, and we were considering mapping Rust to MLIR and doing the analysis and the isomorphism mapping to the kernels in MLIR." That's how he first said it,
Hmm.
which doesn't make a lot of sense because I mean, there is one language there, like about Clang IR, right?
Hmm.
So Clang IR now maps to MLIR. So
Wait,
maybe
since
it's
when?
not the. I mean, Clang IR is for forever. That's always been with Clang IRs.
No,
So
it only goes to LLVMIR. Like,
No, you're thinking about the wrong thing. You're thinking about Clang,
no, I'm thinking about there's
the
there's
Facebook project.
there's Clang IR, which is the new, and I looked
Yes.
into this because I wanted to use it as a front end for hair, and it only lowers to LLVMIR as the sorry, it lowers to the
No,
LLVM
so,
dialect of MLIR.
no, sorry. What? Yeah, whatever they're lowering pads. Yeah, you're probably right. But what I'm saying is, hey, there's now a major language that lowers to MLIR first.
Hmm.
I don't think there's any other, right? Like PyTorch doesn't count, or TensorFlow doesn't count. TensorFlow is not a language, right? But C++, which now is like a front end for MLIR, and then further, but ultimately the target specific code gen is done. But that's not the point. Like Rust has its own IRs. Is what I was thinking when he said that, right? And like if you wanted to do the pattern matching for the kernel library, like I don't need like MLIR is nice, but I don't need to do that. I can just find patterns in the MER or the HER. It's
Hmm.
HIRMI. Anyway, so that was like I think what I got out of the 30 minutes with him, and that's it was a 30-minute conversation. But yeah, I don't know. I'm gonna have another conversation. He kind of like pitched like the business model is they want to be. He kept saying it. They want to be a SaaS company for other companies that want to do ZK for their own products. Like you and I were talking about, like, well, what is the exit strategy or whatever? He's like, that was the first question I asked him. He's like, we want to be a SaaS company for ZK. That's what he said. That's what he's like. We know ZK very well. We need a compilers person, but our business model is to be a SaaS company for whomever that wants ZK services. I'm like, who the fuck is that?
Yeah, I don't know anyone who wants ZK services.
Do you know people that want FHE services other than Google?
Yeah, yeah, yeah. If it was fast enough, I know a lot of people that would want it.
So like, what sector?
like government wants to do stuff on public clouds. They stop wanting. They don't want to run their own data centers anymore. They want to take as much low low secret classified information, uh, like not like this top secret stuff, I guess. I'm not sure what exactly, but the more, they're sick of running their own data centers apparently, and they want to run stuff on Google Cloud, and that was all of the like infighting at Google about Project Maven. I don't know if you heard about any of that stuff. It was like,
No.
yeah, there was some like project, I don't know, maybe 4 or 5 years ago that was like, it was basically like Google's going to design some convolutional neural network system that would identify targets in war zones, like something
That's,
like that. Yeah, yeah. And
uh,
and I, and then they said then there was like a big protest and all these walkouts and stuff, and then Google said, okay, we're not doing it anymore. And then everyone's pretty sure they still did it anyway. They just locked down the security of the code
sure.
so that people couldn't just snoop around in Google and find it. Um, yeah, so
I
that's like yeah, so there's like more and more like government contracts that clouds like Google and AWS are trying to secure, and then they're really focused on privacy stuff. But there's also just like yeah, there's like a lot of people just don't trust Google anymore. They're like stewards of data.
so like the finance banking sector.
Yeah, finance, banking sector very much. And they also don't trust each other. Like I've heard about a bunch of banks that are like, we want to train something uh, over our data, but we don't want to, share our data. So that's kind of like MPC stuff, but they also do it with FHE because it's like not even across banks. It's like within a bank, like different departments aren't allowed to look at each other's
Oh
data.
shit.
Yeah, and there's like groups who like they're basically like, okay, I don't know if you've heard of open source intelligence. That's like these groups that will basically scrape the entire internet for just like stuff like social media profiles, whatever they can, and then they'll data mine that for whatever they're looking for. And some companies will do that and then sell their database basically as a service. And then there are like some groups and companies where the like cross department strictures are so bad that like if that like the both departments in the like government agency or whatever will separately buy an entire open source intelligence database and not be able to share it with people like down the hall. Uh,
And so
And so they're saying like, okay, well, what if we just like had one group that did this and then did like FHE because like the queries or whatever they want them to be like private. It's not that the open source, but like what they're trying to do with it is what's private. And so like,
bro,
okay,
that's
could we
good.
encrypt like so like could you encrypt the query that you're running on a database and then but then have the database be hosted by like Google and it's like public information.
But do you understand? To me, that sounds like our IT services suck.
Yeah.
We can't trust that the logs won't leak or be fucked up or just something. So we're gonna use the highest tech and we're gonna pay through the nose for it in services costs and like hardware costs because our IT services department can't guarantee beyond the shadow of a doubt that the logs won't leak. That's amazing.
Yeah. But
That's
like
beautiful.
we
That's
have
beautiful.
like stuff like lots of like enterprise customers of Google can like encrypt all their traffic with their own encryption keys if they want. Um, but then,
The outside looking in is I get it, but like
yeah,
the situation where you just described, where I have two departments and they're like,
yeah,
we're
it's
gonna
messed up.
use FHE. Yeah,
Someone actually suggested to me that like they had seen this so much that FHE might even be a climate friendlier solution, just because there's so much duplication of data across. And I was like, I don't
I
think
don't think
I
so.
don't think
Yeah,
so.
yeah.
But it's like a nice idea that's like, oh, it's like somehow it's going to enable more sharing of things in some sense, and then like reduced overall like duplication of
So,
things.
so what's the gap? It's you've told me this before.
It's bad. Like, I mean, okay, this is not really about compilers, but the huge news that dropped this week was this
Yeah,
polynomial time quantum algorithm attacking the security foundation of all FHE schemes and doing a pretty damn good job of it. The
uh,
jury's still out on that, but there's two different classes of schemes, three of which are in one category and one of which is in the other category by itself. And the three
Mhm.
that are in these are like better at processing, like better at throughput, processing lots and lots of data. There's some SIMD
That's the one they
parallelism.
broke. That's
Those are the three that they broke,
of course.
allegedly. And then the other one is not broken. I mean, of course, it's still like at risk, but that's the one that is that I have the most experience with and is more not as good at throughput, but better in latency. Um, so and like more universal. So like you can do in this one scheme by itself called uh, CGGI is what I call it after the authors.
Mhm.
But people have implemented like a processor entirely in FHE using that method because it allows you to do stuff unbounded. Whereas the other methods, they have like kind of a limit on how much you can compute before either the parameters get too big or it becomes
Mhm.
unreasonably slow. Um, but so like the slowdown is not that bad if you use these SIMD friendly ones and you're doing things amortized. Like the slowdown
Mhm.
is actually like some people are saying they're getting it down to like 1,000 or 100x slowdown, like with
Mhm.
their most recent chips they're working on. I Jury's still out on that. But the one that is the one I'm familiar with and I have a lot of experience with, it's like one gate is like order of magnitude 1 millisecond. Um, and that's
What?
one, yeah, yeah. So
Wait,
that's a million times
one circuit eval gate. We're not talking about a
one
generic transistor.
circuit, one circuit
Yeah.
eval gate. Yeah.
Yeah.
So like you want to do one XOR operation, or you want to do one like 3-bit lookup table. That's like the fastest ones are like half a millisecond, and then those are like on FPGA. So then you get some SIMD parallelism there as well. Um, And so the result is actually not that bad. But if you're talking about like a CPU, single-threaded CPU implementation, it's like the best single-threaded CPU implementations are currently between 5 and 8 milliseconds for one gate. And so when I say 1 millisecond, I'm rounding down. Uh,
Wait, why did the gate time go up when you say gate? Did you just change your definition of gate? Why does the gate time go up for the CPU
no, I just I
implementation?
just I just rounded down when I
Okay.
said 1 millisecond. Order mag because some of the hardware specific ones are half a millisecond. The CPU ones that aren't hardware specific are 5 to 8 milliseconds. So I just picked something in the middle.
Okay,
Yeah.
but a CPU operates at a higher level of abstraction than a gate. So like how long for a register file read? Or how long for
Oh,
because I
nobody
mean
nobody
like,
nobody writes programs like that, right? You convert your program to a circuit, and then you simulate that circuit on CPU. So that's what I'm saying is the. Does that make
what is
sense?
a CPU? They have you said they have implemented CPUs.
That's
Do you
different. So
mean
so so those are really really bad. I'm just talking about like I have a program I want to run in FHE, then I will convert my program to an arithmetic circuit, and then
Mhm.
I'll or convert it to like a Boolean circuit, and then I'm going to evaluate that Boolean circuit in my FHE library that does the crypto for each gate. And then I'm just saying, like, what's the cost of running each gate in that setting? There's a completely different setting where someone said, okay, I'm going to take the processor architecture for some like really small, I don't even know what it is, RISC-0, RISC-1, like some like really, really small processor architecture. And then they say, okay, now I can like run like just like any arbitrary program.
Linux? Yeah, yeah.
Yeah, I
Yeah,
could
yeah,
run a
yeah.
Linux kernel through my
Yeah,
FHE
yeah.
thing, right? And those ones are like even worse because the process of evaluating a gate, it does like an opcode
Yeah,
switch
yeah.
on the opcode, and so it's like I don't know, like 1 second, 2 seconds per gate operation. Like it's really bad, even worse.
Have people done practical demos where they literally sit there for like 5 weeks for one conditional, one loop, or like one
So
A
people
plus?
people have people have done like takes 1 week to run logistic regression training on like a not huge data set. Like people have waited a week and said like, okay, I have these two banks. I want them to be able, I want to train logistic regression on their combined data, but they don't want to share data. So, and we only need to do this once a quarter. So I'm going to run it and it's going to take a week and that's fine. And I know like,
But that's great.
yeah, I know. Yeah, that's great. I mean, that's what FHE is promising. And I know at least one or
Now,
two,
what? How
like
many? How many design variables in the logistic regression, or how many
I
neurons,
think it's
however you want to put it,
like 30 dependent variables or 30 independent variables, and
and how much data?
I don't
Like how
know.
many
I don't
training? Like,
remember. I don't remember.
I
Uh,
mean, that's not a lot at all by modern means for logistic regression itself.
no,
But
it's like the
like
logistic regression would take a minute to train, right? Like at most.
a
Uh,
minute for 30 variables, how much data you got? 10 good gigabytes?
yeah,
Like for
10
30
second, 10,
variables,
yeah, a second. I don't know.
10.
It
Yeah,
was
yeah,
really,
yeah,
really
yeah,
fast.
yeah, yeah, yeah.
But yeah, this was some like it was some like Brazilian bank that was doing this. Um, but they aren't doing like a FHE processor. That's like the only people who have tried to build like an entire processor are like grad students just like
Yeah, fucking
dicking around
around.
in a final project or
Yeah,
something. Yeah.
yeah.
Um, yeah, and so but yeah, so the that's a 1 million times slow. I think I did the math at one point where it's like one op, like a 32-bit add op or a 32-bit mul op is like whatever 2 nanoseconds or something on a modern CPU, um, and then a single gate, which is not even like a 32-bit
Mhm.
addition op, is going to be more than 1 million times slower than that on CPU. So it's bad.
And yeah, silly is the word. It's not absurd. Absurd is like walking to the moon. That's absurd. Walking to the southern tip of Latin America is silly. It's doable, but like why?
Yeah.
Well, okay, wait. Dumb question because I haven't done the literature. Like I know so little about ECC, but I did read like for 2 seconds some paper. Was part of a reading group a couple of years ago. Um, is the most of the expensive evaluating ECC primitives that you need to perform the actual polynomial arithmetic? Like you need to pivot the point a bunch of times around the polynomial. Like you're looking for some point on a polynomial curve, or some you're doing addition in polynomial projective
Hmm.
space or whatever it is, right?
Yeah.
And my pictographic diagrammatic memory of what that actually means is I'm bouncing around, right? Because the addition is the intersection of two lines or something like that. You like
Hmm.
something like this, right?
Hmm.
I mean, I got it
It's
really
it's
bad,
the
right?
it's like you one point you look at the tangent line
Yeah,
and
exactly.
then you intersect and then you reflect across the
Yeah,
y-axis.
exactly. And so an addition is, but I don't know. It boils down to like I gotta do polynomial arithmetic, right? So it's not just polynomial evaluation. I gotta do arithmetic with polynomials.
I don't think it's
You were
arithmetic of.
tell, I mean, you were telling me about synthetic division
I
the
mean,
last time,
so I think we might be talking about different things.
possibly.
Yeah, I mean, like you're talking about like the elliptic curve stuff that you would use in zero knowledge proofs,
No,
or
how do I add 2 points in ECC?
yeah, I mean, it's like a formula that involves basically solving the intersection of a line with a quadratic, I think. And that's like a formula that you just solve for. I actually have written a blog post about this. Let me see if I can find it.
Okay, fine. So then the simpler question is, okay, what is the really expensive bit that takes a million X? I'm about something to do with polynomials, obviously, but what
Well,
thing
so
in
so
polynomials that?
you're saying in FHE.
Yes, yes, yes.
Yeah, so in FHE, the expensive thing is um, in this one scheme, right? The one that I was talking about with the whatever 1 millisecond per gate. So that one, each gate operation requires you to do 800 sequential accumulations of the following form. So you have 800 of these things. Each one of them is a relatively small matrix vector multiplication, but each entry of the matrix and each entry of the vector is like a 1,000-degree polynomial.
Okay.
So that is the core computational problem. You're
I mean,
doing matrix vector multiplication, sequentially accumulate into into like a 1,000 length vector, and then you're doing this 800 times to get the output of the gate from the inputs.
the elements you said are polynomials.
Yeah.
So then I multiply two polynomials. Yeah.
Yep. Yeah, but you need to
Yeah.
multiply two polynomials, you know, inside each entry of the matrix. And the matrices are not big. They're like I think the one I'm working with right now is like 18 by 3 is the matrix and 18 is the vector. So there's like a total of like 54 elements in the matrix. It's like not that huge, but then it's 54 times 1,000. Um,
The matrix. The matrix. Sorry, the polynomials you said are a degree 1,000. What?
yeah, 2 to the 10.
Yeah.
Uh, and so, and like some of these parameters are wiggleable, depending on how much security you want and all that. Uh, but the way that people get around that is they either use a Fourier transform or a number theoretic transform to convert the polynomials
To,
to a
to
pointwise
frequent. Yeah.
representation and do pointwise accumulation of these things. And then you get into a different problem where like the Fourier domain is not always appropriate for the type of thing that you want to do with these polynomials. So like sometimes you have to switch back, and so then the NTTs and FFTs end up being the bottleneck there. Um, but that's like an
Yeah.
implementation detail because if you could, like in the case of the TPU thing I'm working on, we just used the matrix multiplication unit, and then we don't need to do any FFTs.
But but the elements of the matrix are polynomials. So you're doing like what matrix multiplication unit? The
Yeah,
matrix
you have
multiplication
to,
unit.
yeah, yeah, it's a very specific,
You
the polynomial multiplication has a way to represent that as a matrix multiplication, but you have to take one of the
yeah.
polynomials and expand it to a matrix and like
Uh-huh.
shift
Yeah,
some
yeah.
of the rows around and flip some signs, and then
Hmm.
when you do it,
Hmm.
you get back the original. Yeah, I wrote a whole blog post on that topic.
In NTT space, so the thing that you said that the frequency space isn't necessarily the right space at certain points. So, like, I think you're saying, well, I carry out this calculation computation, and sometimes I can move to frequency space, and sometimes I can't move to frequency space. And at those moments when I can't, I have to go back to the
Yeah, like say
convention.
that you wanted to compute an operation which was like uh, okay, so like you might have some data that's represented, like you have your polynomial, uh,
Mhm.
and you represent your data so it's like each value in your tensor is like one of the coefficients of the polynomial.
Mhm.
So if you multiply two polynomials in that form, then you'll actually get the convolution of your underlying data.
Mhm.
But if you do it, if you have your data packed into the polynomial as like evaluations at a particular point, then when you multiply the polynomials, you get a pointwise product. And so it depends on what you want to do with your data. Like if you want to do a lot of convolutions, it makes sense to represent your data in the polynomial in a different way. And so then it's not always there's not always like one right answer for how to represent your data. Like you have to basically do a static analysis of your program to figure out like, okay, what are you doing, and use that to determine how the
But
data
there's
should be laid out.
so the thing that was trying to ask was if you do a DFT of an analog signal, if you don't obey Nyquist criterion, you're going to get aliasing. If you don't
Mm,
sample up frequently enough, right? So you're going to, and so like in in whatever radar design or uh, audio digital conversion or all these kinds of like these people play in the real world, not the digital world. The trade-offs there are sampling frequency, like resolution and all this kind of
mhm,
stuff. And hey, I incur a lot of loss or aliasing or whatever if I want to do low res, low bit depth sampling. But I can, and so that's like the Fourier transform is like if my signal is aperiodic, then I need higher frequency. Then there's like higher frequency components, and I need more sampling frequency. I need to sample at a higher frequency, more resolution, blah blah, right? And so like if I have a low res or low width or whatever you want to call it, Fourier transform of an aperiodic signal, then you could say that the frequency domain is a poor fit for that signal. I've lost a lot of information. And
mhm,
what I was trying to figure out was like in this uh, incantation iteration of Fourier transform. I thought that's what you were saying. Like, well, if I go to the frequency domain, I'm losing something.
So that
You're saying something
happens.
else.
That happens. You get like accuracy loss, and they have to like account for that somehow. I don't know, actually know the details of how they do that, and that's actually one of the reasons why people prefer the number theoretic transform because it's all just integer math. There's no
This,
accuracy loss. Um,
this was the thing that I was thinking. It was like, well, if FT incurs a loss because of like Nyquist sampling, but the NTT I have the sense is like integers or integer
it's just
arithmetic or like,
it's a group theoretic version
yeah,
of
exactly, exactly.
same
Yeah,
algorithm but no physics interpretation.
yeah. And so then there must be no loss,
There's no
right?
loss, right? Yeah. But you have other problems with that one too. Like you have to ensure a lot of specific relationships between different primes and things involved in setting this up so that you get like a guaranteed existence of this algorithm. So and like it's actually kind of funny. The one of the people I talked to who was designing hardware for this said that like they had to change from doing 32-bit native types in their hardware to 64-bit because they ran out of 32-bit primes to use for their and I thought this was funny because I looked it up and there's 50 million 32-bit primes. There's there's plenty of them. But there's enough conditions that get enforced on which primes are appropriate to use and which primes have good performance. Like they have to be like spaced out enough, and they have to have certain residues with respect to each other in order to be usable for some of these schemes. And otherwise you don't get like a valid NTT operation. Uh, or the NTT is slow or something like that. I forget. I don't know if that makes sense if the entity could be slow, but there's some other dimension to it that I'm not fully understanding. But then
How,
he's like, yeah, we ran out of 32-bit primes, and I was like, oh, that's like a nice line.
what conjecture is it? Is it like equally? Oh no, it's equally spaced pairs of primes. That's the
Oh,
Goldbach
twin prime.
conjecture. Or something?
Yeah, twin prime
Twin prime
conjecture.
conjecture.
Yeah, that one's basically proved at this point. This is turned into like math and methamphetamine. This-
Yeah.
but yeah, they proved the twin prime conjecture with, but not with space two
There,
between primes, but space six. That
that
one's
the
been proved.
distance. Yeah, but I don't. I like. I don't appreciate. I don't have like this refined appreciation for number theory. I never did. So, but I'm like you see something sometimes. So like I know that this exists and people care about the shit. The space of six is what? What is that's the minimum distance?
That's the maximum distance. Like so, if you say like there are
Okay.
infinitely many primes of the form p comma p plus six.
And that's okay. So that's the lower bound, or that's the yeah, it's the lower
That's the
bound on the
upper.
maximum distance.
Yeah,
It's the lower bound
exactly.
on the maximum distance. Yeah.
The yeah, that's the upper bound of what they proved. I don't know.
So yeah.
Haven't
Okay.
heard of any updates on that theorem since, because it was like one day someone had proved that infinitely many primes with a gap of like 10 to the 7, and
Yeah.
then like 2 weeks later they got it down to 6.
Yeah. So the guy didn't run it. So the guy, the funny thing is, like, I was thinking about like the reason I came up is like, do they get sparser? But they don't. So he got
They
50
do get
million.
sparser. They do get sparser. But it's not like a uniform concentration of sparsity. So the total number of primes less than or equal to n is n divided by log n. Like statistically, that's
Okay.
the approximate
Okay.
ratio. And so they do get sparser. Um,
So then what is the P? Okay. Yeah. So this is I suck at number theory. This is I suck at number theory hour now, actually. What is the P comma P plus six?
that's
Is
like
that, are
so
the,
it's like you can imagine
those
that
are two
even
primes?
though the primes are getting sparser, like eventually you'll get lucky and you'll find
Oh,
two
they'll
primes
pair it
really
up.
close to
Yeah.
each
Okay.
other, but you
Gotcha.
have to keep going further and further to find more.
Okay. So how many more primes did the guy get by going to 64-bit? Do you know?
I don't know. Yeah, I mean it's like it's whatever.
Just log in it, yeah.
2 to the 64 divided by log 2 to the 64. That's the number of 64-bit primes. So that's a pretty big
Uh,
number.
you got, I mean, log 2 to the 64 is 64. Uh,
Yeah, well, I don't know. 2 to the 64 divided by
between
64 is
friends.
huge.
Yeah,
But
yeah,
like 2 to the
yeah.
32 divided by 32 that's easy to sort of estimate in your head. It's 50 million because 2 to 32 is like 4 billion,
Yeah,
right?
sure, sure.
Yeah.
Well, you just subtract. Oh, yeah, yeah, yeah. Yeah.
Sure. I don't know my
So his
powers of two above 16, so I. Yeah, did I tell
uh
you I had a professor that made us memorize powers of two in our it was like a undergraduate algorithms class, and he put powers of two on the exam. Like it was like I think it was like he picked like three random powers of two between 2 and 16, and
you
like
know what I would have done? You know what I would have done out of the spite? I would have written the binary representation.
oh, okay.
Because I like how are you gonna fault me for that? That's the number.
Yeah,
Okay, maybe 2 to the 64 is not an evaluated number, but if I give
yeah,
you the binary representation, how are you gonna debate me on that? Like,
yeah.
I know it's in
His
base 10. Did he
his
specify base 10?
his reason he did I don't remember he probably did but like his reasoning was very much like you will see these numbers in base 10 and in hex like you'll so like if you happen to recognize them then you'll be able to like spot patterns when you're debugging
Yeah,
things
yeah,
and I was like I kind of agree with him. He also had a grading robot
Um,
that he nicknamed Bender like from Futurama because he was like a complete asshole.
the robot was an asshole.
Yeah, the robot, it was like a grading robot, and the grading robot, it was an asshole because it would run a bunch of tests on your submitted program, and it wouldn't tell you what, it would just tell you that some tests did not pass, and it wouldn't tell you what.
Ooh,
So then you had to go
that's
back to the
brutal.
spec and like try and like scrutinize your own program to figure out what was wrong with it. And it wouldn't let you submit more
Oh,
than
it
once
hurts.
every 6 hours, I think, once every 6 hours.
That's horrible.
So
It's literally the definition of Kafkaesque. I'm being persecuted. I don't know for what. Every 6 hours, once every 6 hours, horrible.
I think,
I mean, even
his reasoning for that was that like that forces people to go to bed. Like if they submit something and it doesn't work at 2 a.m., then they might as well get some sleep.
uh, yeah, fuck that guy. Did the guy who doubled his bit width got his hardware got slower, right?
I imagine, yeah, because well, I don't know. Does it get slower, or are you just more expensive to fabricate if you have 64-bit as your base arithmetic?
Karatsuba, I mean, like all those, like Karatsuba and Tomasulo's algorithm for bitwise multiplication, they're
Is that
n
what they
squared
actually
in the
use
bit
on a
width.
chip?
Yeah, I mean,
Okay,
what
I
else are
don't.
you gonna do? You gotta, yeah.
I have no idea.
Uh,
Like I don't know
I
what
did.
people actually use to do multiplication on chips.
I mean, I shouldn't say this like I've actually implemented either of these things. Uh, let's see. What is my? I mean, what is my near skin of my neck contact with this? I can tell you the number. Well, okay, I can tell you a couple things. So, for example, when I was synthesizing, so you synthesize circuits, right? And when I was synthesizing like whatever neural nets, the interesting thing was that addition, although like naively you would imagine addition is cheaper because addition is a cheaper algorithm,
Hmm.
addition ended up taking up more gates than multiplication. And the reason was, oh, sorry, it had a higher latency or something like that. And the reason was if you want to add, there are some shifts involved. You got to line up the decimal point, and those shifts end up being expensive,
Hmm.
even more so than whatever the n squared number of operations to multiply a 32-bit number by a 32-bit number with floating decimal point, because it's a floating decimal point because the like the multi, multiply operands or whatever uh, take care of themselves. The fact that they're scaled differently or something like that. Anyway, so I don't know for a fact, but when I was like, well, I mean, what else are they going to do is kind of my feeling on it. There's not, you could do lookup tables for all of the products between all of the somethings, but there's no other way around other than like some kind of Karatsuba kind of thing where you actually do the, oh, bit shift and left, like literal elementary school arithmetic, right?
Hmm.
There's some way to do that a tiny bit faster, but there's no way to do that using an oracle. So there's no other, at least that's my intuition on it. I think that's true. So 64-bit floating, I mean, that's why, for example, if you look at like every press release from NVIDIA, I was told this recently. Somebody told this to me. Like they have press releases where they're like, we have this many teraops, right? Like all our new chips, the teraops are increasing. They are increasing, but the way that they're doing this is they're reducing the precision.
Hmm.
So like all the latest numbers about huge numbers of terops are at FP8. They're not at FP16 even. Brain float 16. They're
Hmm.
at FP8. Yeah.
I I looked it up.
Cool.
There's something called a data multiplier, DADDA multiplier, from the invented by the computer scientist Luigi Dada.
Not Dadaism.
No, 3Ds in Dada. Uh,
So what's the
it says similar to something called the Wallace multiplier. Uh,
what's the complexity? Where is it?
it does all pairwise logical ands, and then stages of full and half adders. Yeah,
Yeah. Okay. So there. I mean, still, right? You gotta literally shift, move bits around. You gotta touch every one of the bits,
sure.
and in multiplication, they gotta all touch each other. It's a
But you
all pairs kind of thing.
get some of the advantage of having a fixed input size, right? Like rather than having to have an algorithm that works for like an arbitrary bit width. And
Ah,
then
that's so. Yeah. So you're right.
we're
Like,
just saying like, okay, 64 things. What's all pairs of 64 th bits? Well, okay, we'll just put that many things on our chip and then it will go at the speed of light, whatever.
okay, so that's 100% true. You're actually 100% right that the you what happened to his hardware was either it got slower or it got more expensive because the area
Right, yeah.
occupied by his multipliers got increased. Yeah,
Yeah. Yeah, we are 20 minutes over when you said you wanted to stop.
it's okay. It's okay. It's okay. It's okay. It's good. It's good. It's good. I was about to call it quits, but that was a good final note.
Yeah. And
Yeah. Cool.
no one came to ask any questions this time. Oh,
Can I say? Can I
shit.
say? Can I?
Someone did
What?
have a
What?
question. Oh my gosh, I'm not looking at the chat. Someone named Lo Huis says, I got a question about Clang LLVM. I want to annotate loops or statements in C++ code with a pragma and then run a machine function pass in the backend where I modify these according to my needs. I've already
Holy
got the
fuck.
machine function pass working, but what's the best way to get pragmas through to the backend? I actually had the same question. I wanted it to go through Clang IR or Polygeist, neither of which support pragmas, as far as I know.
Oh.
But I wanted to figure out like how can you get a because I want to be able to have a pragma that says like this data type is private, and I have no idea
In
how to
C
get
in
that.
C++ in C++.
Yeah, you say on like a function or on a like yeah, and then have that like propagate. Basically,
Sorry.
I can annotate an MLA, or I can say, oh, this SSA
Yes,
value,
but
I can, or the in the function signature, I can say this
sure,
argument of the function has a private
sure.
annotation, and then I can use that to like
Yeah,
start my FHE computation.
sure.
And then the question is, how do I get that from the front end into the compiler? And I
You
don't
just need a
have
different.
a
You just need a different front end. You need a completely different front end. You guys are all messing around with this idea of like I'm going to use existing language front ends and then I'm going to like bolt on or interject. And I propose to you that you need a new front end. But okay,
well,
I'm just fucking around.
what happens to the pragma? It's in the Clang AST for sure, right? It's got to be.
Sure, but Clang doesn't give a shit about it. Yeah,
Right, but
I
then
don't know that.
if you're lowering something from Clang AST like to something like LLVM or MLAR, can't you uh, add a little thing that says if there's a pragma, like convert that to
No, 100%. I'm
yeah.
100%. No, of course, there's some like go figure out how. I mean, there so are there actually so you can just go look at how OpenMP is implemented. So OpenMP,
Hmm.
which abuses the shit out of pragmas, right?
Yep.
Must uh
You must do something.
it's interesting because OpenMP doesn't ship, does it? Does it ship its own Clang? No, yeah.
I don't think it does because I've used
Yeah, so
OpenMP
exactly.
and I didn't use a custom Clang.
So you're exactly correct that like the pragmas are preserved at the AST level and then OpenMP intervenes and just captures them, records them, does something with them, manipulates them. So Yeah, I don't know the answer to this because I don't spend a lot of time in conventional LLVM land.
Ah,
But my approach would be
yeah, now the chat says the same guy, Lewis says, no, the pragma is not in the AST. I need to convert it to a C++ attribute.
what? What is a C++ attribute? How
I don't
does
know.
OpenMP work? Like,
This is
where's this
beyond
guy?
my knowledge.
Where's this guy? Why isn't he just join us on here to debug this? But also, he should come back in 2 weeks, or he should ping me or you if you're up for it on Discord because we're signing off. Um, where is this guy? I don't know how to flash, but I posted my name in the he found this thing through Discourse. I posted my name. Reach out to me, man. I'll help you out to the best of my abilities if you are actually trying to solve this
Yeah,
problem.
and put maybe if you're on the LLVM Discord, definitely post something and tag us in like the I guess in the Clang uh channel.
Or yeah, sure. You can either go to the Clang channel or you can just DM me directly, and I'll try to help you debug this, figure this out.
Yeah. Thanks for the question. So I feel like that I have no idea how long this chat message was sitting here waiting for us to answer it while we
Well, but he was
blabbered
at least
on
still there.
about.
Yeah, fine, but at least he was still there for or
Yeah,
him or
yeah.
her or them to hear our response to come reach out.
Excellent. Cool.
Uh,
All right.
yeah, but you
Well,
should just use a different front end. But anyway, we'll talk about that later.
all right. I will
All right,
yeah. See you next time, Max.
see you, man.